Okay, so let's start with our first topic, which is get started with data warehouse in Microsoft Fabric. All right. So first, let's decide or let's choose that what we need to choose from warehouse and lakehouse. Okay. So when we talk about the warehouse, it provides the structured data. So data warehouse basically is optimized for relational data with predefined schemas. And here we need multi-table transactions. So data warehouse, it support as a transactions across multiple table. It also provide high performance by handling the complex queries and large data volume efficiently. It also provides us expensive security. So object level like table view, function, stored procedure, etc. Column level, row level, DDL, DML, dynamic data masking. All right. Now, when we talk about the lake house, so it provides us with diverse skill sets, like developers can use PySpark, T-SQL, or notebooks to work with the data. Here, we also work with the semi-structured or unstructured data. Okay, so it can handle various data formats with the schema on it. Okay, then Lakehouse can scale up or scale down as needed and pay only for what is used. All right, and Lakehouse can leverage Delta Lake features such as versioning, time travel, and upsert. So it also provides us the T-SQL security like row level, table level. All right. So now we know the difference between the data warehouse and data lake house. Okay, so now let's try to understand Microsoft Fabric Warehouse. So Microsoft Fabric Warehouse is a complete platform for data analytics and AI. It refers to a process of storing, organizing, and managing large volume of structured and semi-structured data. So data warehouse in Microsoft Fabric is powered up with Synapse Analytics by offering a rich set of features that make it easier to manage and analyze data. It includes advanced query processing capabilities and support the full transactional T-SQL capabilities like an enterprise data warehouse. Okay, and unlike dedicated SQL pool in your Synapse Analytics, a warehouse in Microsoft Fabric is centered around a single data lake. So the data in the Microsoft Fabric warehouse is stored in Parquet file format, and this setup allows users to focus on tasks such as data preparation, analysis, and reporting. It takes advantage of the SQL engine's extensive capabilities, where a unique copy of their data is stored in Microsoft OneLake. All right. So now let's see how can we create a data warehouse in Fabric. So Fabric data warehouse basically is a relational data warehouse and it support full transactional T-SQL capabilities. Okay, so there are multiple ways through which we can create items within a fabric. All right, so either we can navigate to the fabric workspace and then we select the new item from the warehouse. Okay, or we can create it using the create hub. Now, when we talk about designing a dimensional warehouse, so tables in a data warehouse are typically organized in a way that support efficient and effective analysis of large amounts of data. This organization is often referred to as dimensional modeling, which involves structuring tables into facts and dimension tables. Alright, so let's talk about fact tables first. So, fact tables basically it contain the numerical data that you want to analyze. Fact tables typically have a large number of rows and are primary source of data for analysis. Now let's talk about dimension tables. So dimension table contain descriptive information about the data which is there in the fact tables. And these dimension tables typically have a small number of rows and are used to provide context for the data in the fact tables. Now there are two unique keys that are present. First one is surrogate key. So it is a unique identifier for each row in the dimension table. It's often an integer value that is automatically generated by database management system when a new row is inserted into the table. Then we have alternate key, which is often a natural or business key that identifies a specific instance of an entity in the transactional source system, such as a product code or a customer ID. So we need both the surrogate and alternate keys in a data warehouse because they serve different purposes. Like surrogate key are specific to the data warehouse and it helps to maintain consistency and accuracy in the data. In the same way, alternate keys are specific to the source system and it helps to maintain traceability between the data warehouse and source system. Okay, so the schema that we can see here is a star schema. Now, if there are a lot of levels or some information is shared by different things, so it might make sense to use a snowflake schema instead. Okay, so in this case, we can see that dim product table has been split up or normalized to create separate dimension tables for product category and supplier. And each row in the dim product table contains key values for the corresponding row in dim category and dim supplier tables. Now, if we talk about a dim geography table, so this table has been added and it contains the information on where customers and stores are located. And each row in the dim customer and dim store tables contains a key value for the corresponding row in the dim geography table. All right. So now let's move ahead and see what special type of dimension tables we have. Okay. So these some special type of dimensions provide additional context and enable more comprehensive data analysis. So we have two such kind of tables. One is time dimension. Okay. So time dimension provide information about the time period in which an event occurred. This table enables data analysts to aggregate data over temporal windows. For example, a time dimension might include column for year, quarter, month, and day in which a sales order was placed. Then another special type of dimension table is slowly changing dimensions. So these are the dimension table that track changes to the dimension attributes over time. Like changes to a customer address or a product's price. So they are significant in data warehouse because they enable users to analyze and understand changes to data over time. And slowly changing dimension, it ensures that data stays up to date and accurate, which is imperative to making good business decisions. Now, ingesting the data into a data warehouse. So, there are few ways to ingest the data into a Fabric data warehouse that include pipeline, data flows, cross database querying, and the copy into command. Now, after ingestion, the data become available for analysis by multiple business groups who can use features such as cross database querying and sharing to access it. All right. Now, once the data is loaded into the data warehouse, many of the points will be familiar for Power BI users. Now that you know how to implement a data warehouse in Fabric, let's prepare the data for analytics. So, there are two ways to query data from your data warehouse. And if you are comfortable with T-SQL, you may prefer to use the SQL query editor to write your queries. So the SQL query editor, it provides a query experience that includes intelligence, code completion, syntax highlighting, client side parsing, and validation. And if you have written the T-SQL in in your SQL Server Management Studio or Azure Studio, you will definitely find it familiar. So to create a new query, use the new SQL query button, okay, just there in the menu, and you can author and run your T-SQL queries here. All right. Now another way is visualize queries in Fabric, and for that we have Visual Query Editor. So this Visual Query Editor, it provides a no code drag and drop experience to create your queries. Okay, you can use the new Visual Query button to create a new query. Can drag the table from your data warehouse onto the canvas and to get started. And then after that, you can use the transform menu at the top of the screen to add columns, filters, and other transformations to your query. You can use the plus button on the um, visual query editor, okay, itself to perform similar transformation. Now building a relationship. So relationship allows us to connect tables in the data model, and creating a relationship between the tables in your data warehouse using a click and drag interface in Fabric in the model view. Okay, so you can drag the column from one table on the top of the related column in another table. Now, every time a data warehouse is created, Fabric creates a set for analysts and or for business users to connect to for reporting. So, data sets basically are semantic model with metrics that are used to create reports. If we simply put, analysts use the data model to create that we have created in our warehouse, which is stored in a data set. If we are familiar with Power BI, then working with the data set which is created by the data warehouse experience will be straightforward. All right. So these data sets are automatically kept in sync with the data warehouse. So you don't have to worry about maintaining them. And you can also create custom data sets to meet your specific requirement. Now, visualizing data. So, Fabric enable you to visualize the result of a single query or your entire data warehouse without leaving the data warehouse experience. Exploring the data while you work to ensure that you have all the necessary data and transformations for your analysis is particularly useful. You can use the new report button to create a new Power BI report from the contents of your entire data warehouse. So, using the new report button opens the Power BI service experience where you can build and save your report for use by the business. All right. So, with that, we have come to an end with our first topic. And now let's switch to the demonstration tab of our Microsoft Fabric portal so that we can see that how can we analyze the data in data warehouse. Okay, so let's start our demo of analyzing data in data warehouse. So for that, we will be selecting Synapse Data Warehouse. And inside it, first of all, we will create a workspace. So we have created a workspace. Now I will go on the home page of Synapse Data Warehouse and I will select the warehouse. I will create a warehouse. Okay, so from here we will select the T-SQL section. So here we will be creating table and inserting data into that table. So let me replace the code. So here we have created a dim product table. So if I look into the schema and tables, I can see a dim product table here. Now let's insert some values in it. So for that, I will select new SQL query and I will insert some rows in it. Okay. So let me just select it. And here we can see that 3 rows have been inserted here. All right. So now I have opened a T-SQL code, which is generating a data warehouse. All right. So I'll just copy the code and I will paste it in new SQL query. So it is creating a simple data warehouse schema and loading some data into it. All right, so now, all right, so now let me just, okay, it has been refreshed and we can see that there are 4 tables now, 3 dimension table and 1 fact sales order table. All right, now we will define a data model. Okay, so at the bottom, we can see that we have a model tab. So if I click on model tab, we just minimize the property and minimize this. Okay. So we can see that we have dim customer, dim date, dim product table. Then we have fact, sales order table. Then we have other tables as well. All right. So now what we will do, we will arrange the fact table first. Okay. So what we will do that, we'll just select the fact table. Let's first arrange our tables. So that all the tables are clearly visible. Okay. Now from the fact sales order table, we will drag the product key and we will drop it on the product key of dimension table. Okay, so let's do the step. So product key. All right, so here I'll just hold it and drag it to the product key. So now here first table is fact sales order, second table is dim product, column is product key in both the tables, and cardinality we will select many to 1 and cross filter direction will be single. All right, and we are making this relationship active. So now we will click OK. So we can see that our relationship has been created between fact sales table and dim product table. All right, now we will perform the same steps with the customer key in fact sales order table and dim customer table. So let me just drag it, customer key from here to the customer key here. Same, we'll be selecting many to 1 only. And now I will be doing same with the dim date key. So I will for date key, we'll select sales order date key column and we will drop it on the date key. Sales order date key. Okay, 1 minute. Let me just minimize it a bit. Okay. So now we can view the relationship that has been built between the tables that has been created. Okay, let us All right. Now we can also query the data warehouse table. Okay, so for that, what we will do, we will create a new SQL query. Let me now max. Okay, and in new SQL query, let me query all the tables. So we are here joining the tables, and then we are also grouping the data, and then we are sorting the data. Okay, so let's run it. We can visualize our result. Okay, now we will modify the query, and we will also add a second dimension to the aggregation. Okay, so now we have joined two dimension tables here with the, we have joined dim date table with dim customer table, and now let's run it. So now let's explore the result. Okay, so now we can see that here now we have columns like which are aggregated by year, month, and sales region. All right. Now let's create a view also. So in data warehouse, we can also create objects like views and stored procedure to encapsulate SQL logic. Okay, so let's open a new SQL query. And here, so basically we are creating vSales by region view, okay, in which we are joining the fact table with the dim date and dim customer table. Okay. All right, and now it is successful. So let's just explore, and now we can see that a sales by region view is there. Okay, now let's explore what data is there inside this view in a new SQL query. So let me just write the code of selecting the sales by region view. Let's run it. So here we can view the data which is there inside the view that we have created. Now we can also create a visual query. Okay, so for that we will click on new visual query, and here let us drag the fact sales table on the canvas. Let's just close all these tabs. Okay, so let me drag it here. So we can see a fact sales table here, and we can see its preview is also there in the preview pane. Just minimize it a bit. All right, so we can see its preview in the preview pane. All right. Now let me drag one more table here. Let's drag dim product table. Okay. So we have fact sales order table and dim product table here. So now what we will do, we will use the plus button here. Okay, and we will use the merge query. All right. So now what we will do in the merge query window, we will select the dim product table as the right table for merge. Okay. And join kind, we will use left outer join. And now we will click OK. Okay, join keys. So we'll select the product key as join key. Okay, so now we can observe that the two tables have been merged. Okay, and if we look at the um, preview pane and if we look at the fact sales order table, we can see a new icon here of merged queries. Okay, and we can also see a new column dim product table. So if I maximize it, I can select which table I want to select, which column, click OK. And here product name column is there now. Okay, so this is how you can work with your data warehouse. So let's go back to the slide.